working here. Let me try that again. Yeah, here we go. All right, so quick word about the exam. You should have gotten an email me back from me about the exam. 10 questions. Most of the exams are like this, 10 questions, 10 points each. So I gave you a breakdown of how you did on questions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. Okay. Most of the exams are good, and that was particularly pleasing to me, especially since, you know, I was gone the whole week, sort of, but you made up for that. Many of you did better the second test than the first test, which was also good. I know sometimes, you know, the first time you get a new teacher and you don't know what the teacher's like and all that, so, but now that you've had that, you can see what it's like. Yeah, Max, what did you want to say something?
Yeah, I'm just going through the beginning of chapter 3. We don't really have any homework for that chapter.
Chapter 3? I'll go over that in a second.
Like, it says 3.1, but we don't have any homework for 3.1. It's just
right. If you're talking about this, yeah, I realize that ahead of time. I mean, I'm talking briefly about 3.1, but you're right. There was no homework in 3.1, and that's borne out over here. And by the way, I'm changing the assignment already, so go ahead and make a note of this. It's on the recording also. So 3.32, change it to 7 to 33 odd. I know this is all messed up now. But a lot of the reason for the mess up is to throw out a lot of problems, right, when I was gone for a week. 7 to 33 odd, but also skip 31B as in boy. So 3.2, change it to 7 to 33 odd, skip 31B. Okay. So yeah, about the test, you should have your test back. If you're not sure about it, email me back, but I think I emailed you back all your scores, got your homework recorded, and the grading scale again is 90, 80, 70, 60. So 90% an A, 80% a B, 70 is a C, 60 is a D, less than 60 is failing. But most people did okay on this test. Again, I was pleased with that, especially since, you know, this was a crazy week where all I could do was just email you notes and try to make a little mini video out of my cell phone, but you guys came through pretty well on that. Okay, so we've had 2 tests down. We have 6 total, so we're here. We're about 1/3 of the way through of the course. Okay, so looks like the next test is in 3 weeks. So quiz Friday, Friday after that, and exam looks like it's October the 9th. That Friday will be the next test. Okay. And again, the quizzes are just like the previous quizzes. You get to talk about it. It's very, all my quizzes are very low key. And I should say all my quizzes now, when we're under shelter in place, are like that. I don't necessarily teach this way. We were meeting face to face, but you know, they gave us directives that we just got to make things easier for everybody, including myself, because we were doing, you know, shelter in place and Zoom and couldn't meet face to face. So I decided one way to make it easier on you guys is to give you quizzes, which are very low key. You can help each other out, and you have the whole weekend to do it. All right. So, I mean, you don't even have to study for the quizzes, frankly. But I wouldn't do that if we were meeting face to face. So let's say by spring 2021, if we were meeting face to face, I would not do a lot of the stuff that I'm doing now. I'll be back to what I normally have. Like for quizzes, I would have what you normally think of as a quiz, where you know you can't talk to each other. I would only give you maybe 10 or 15 minutes to do the quiz or so on. Okay. All right, so that's that. Somebody is unmuted. Can you please mute yourselves? Whoever's out there is talking, if you can mute yourself. No? Somebody's still talking. Hello? Otherwise, I have to fiddle and try to find out how to mute everybody. That take me too long. You just help me out if you could mute yourselves. Thank you. All right, so that's that. Again, if you have a question about your individual tests, your individual scores and all that stuff, send me an email. It shouldn't take up class time for that, but you're always welcome to email me about how you're doing and so on. Okay? And by the way, you get to drop 1 exam. So we have 6 exams total. We've had 2, and so you get to drop 1. So you might say, oh, I bombed out on a test. You can drop the 1, but you know, normal strategy, you don't want to use up your makeup, or sorry, your drop too early, because that means that forces you to do better on the other tests. Okay, so this Friday quiz, Friday after that quiz, and Friday the 9th, I guess it is is the next exam, and that'll be about halfway through the course. That's week number 8. Believe it or not, I think we're already starting week 6. Let's see, 1, 2, 3, 4, 5, 6. Yeah, we're in our 6th week, believe it or not. Okay, I know it may not have seemed like it because this week, you know, we never met because my computer was down, or not my computer, my internet was down. That's the way it goes. Okay, so there we are. So I'm going to get started with 3.2, and yes, just a brief word about 3.1, but yeah, you're right, there's no homework problems on it. And the assignment again is 7 to 33 odd, skip 31B. Okay, and yeah, you might complain, this looks so messy now. Well, it's to your advantage. I'm throwing out problems basically. I only put in very few extra problems, but I'm throwing out a lot because we're in shelter-in-place and so on. So if we were meeting face-to-face, we probably would keep a lot of these problems that are here. And, you know, we would have met face-to-face, and assuming, you know, we wouldn't have lost a whole week because, you know, my internet was down and so forth. Okay, so that's enough of that. Let's get started. So chapter 3. We're doing polynomials now, mostly. Okay, so algebraic functions, chapter 3. 3.1 on page 128 is an introduction. We're doing polynomials. Here's a general form of a polynomial. I don't think it's worth memorizing or even looking at. You've all seen polynomials. Polynomials have degrees, like 0 degree, 1st degree, 2nd degree, 3rd degree, and so on. Okay, so the exponents on the x are like x to the 1, x squared, x cubed, x to the 4th. No square roots, no fractional exponents, no decimal exponents, or anything like that. Okay, so on the top of 129, a square root function is not a polynomial. Okay, it's called algebraic, but it's not considered a polynomial. This is a rational function. It's something divided by something that's not a polynomial. So right now we're only discussing polynomials. Okay. So polynomials in general look like this. So that's basically it for 3.1. I'm quote unquote done with 3.1. But here are a bunch of polynomials. So if you look at these polynomials on page 129, there's no square roots on the exponents. The exponents are all positive integers like 6, 4, 2, 1. This has no x at all. X cubed, x squared, x to the 10th. So these are polynomials. These are not polynomials having a square root or a fraction like that. They just call them algebraic functions. Okay. All right, and a quick review of some things about polynomials. Okay, so the highest exponent that you see is considered the degree. Okay, the highest exponent. So if you look at this polynomial, right, the degree's 6 because the exponents are 6, 4, 2, 1, and if you see just a number, that's considered degree 0. So the whole thing is considered 6th degree, the highest exponent on the variable. Okay? The polynomial 17 is considered 0 degree because you don't see any x at all. Or you could say 17x to the 0 because x to the 0 is 1. Okay, so that's considered 0 degree. Okay, this one is considered 3rd degree, 2x cubed minus 2x squared plus x minus 5. So the exponents are 3, 2, 1, and 0. So the highest exponent that you see is 3. That's considered the degree. And this one, x to the 10th, that's all you see, so that's considered 10th degree. All right. Okay, then you have something here called leading coefficient. Okay, that's the coefficient, the number in front of the highest exponent. So if you look at the highest exponent, the leading coefficient is -3. Leading coefficient is 17. All you have is a constant. 2 and 1, you pretend there's a 1 in front here, right? So leading coefficient, that's the coefficient of the highest exponent. So we'll refer to that expression quite a bit, leading coefficient, right? It's the coefficient of the highest exponent. And then a constant term. Okay, so a constant term means there's no x at all. Okay, so 1 is a constant term, 17 is a constant term, -5. And this one where you don't see anything, you pretend that there's a 0, right? So plus 0 there. Right, so we're considering something called polynomials now. All right. All right, so that's it for that. We're going to be graphing some polynomials. Okay, so here are some graphs. Okay, don't worry too much about them right now, except, well, this is x cubed. You should know generally x cubed looks like that. Negative x cubed goes that way, and we know how to translate them, right? Move it left, right, up, or down, and so forth. Okay, so we're going to rehash some of those thoughts. And we're going to learn how to graph stuff like this, page 134. Okay, they give you some weird polynomial. We're going to be able to do a quick graph like so. Okay, the easiest thing to do is put down the zeros. We want to find the zeros of the function, if possible, factor. Okay, so a lot of our time for this section or sections of this chapter will be trying to factor, so then we can easily find the zeros. Okay? Now, you'll be doing a lot more graphing when you get to calculus. Okay, so when you get to calculus, you'll be finding, let's say, maximum points and minimum points. What's the highest point and lowest point on certain parts of the graph, but we won't be doing that in general. Okay, again, bottom of 135, we're looking for the zeros of a function. That's a key concept. Okay, the zeros of the function if f of c equals 0. So for instance, right here, there are 1, 2, 3, 4 zeros of the function. That means where y is equal to 0. 1, 2, 3, 4. This one looks like it has 1, 2, 3 zeros. Okay, that means it touches the x-axis 3 times. This one looks like it has 1, 2, 3 zeros. 1, 2, 3 zeros. That's how many times it touches the x-axis. Okay, that's what's called the zero of a function. Okay. Okay, I'm going to talk a little bit about something called multiplicity of a zero. Okay, we'll talk more about it later, but just introduce the concept of multiplicity. That's when you have something like this squared or cubed or something higher, not just x minus c, like x minus 1. Maybe it's x minus 1 squared. If it's squared, we would say multiplicity 2. Or maybe it's x minus 7 cubed, we would say multiplicity 3. Or the exponent is 8, we would say multiplicity 8. Okay? I don't think it's worth writing down, but when we get to it, I'll talk more about it later. Okay. All right, so now some simple graphs involving these. So I'm going to hold off on this just for a moment. And by way of introduction, I'm making up my own stuff here. Okay, so 3.2 polynomial functions. So I'm making up a polynomial here. This is not in the book. So this is one of the rare times I'm actually doing something which is not in the book for illustration. It's not a homework problem. But given a function f of x is 5 times x plus 2, x minus 1 squared, x minus 5. Okay, so suppose you were to tasked with come up with a quick graph of this function. Okay, here's the answer, but how do you get that answer, right? F of x equals 5 times x plus 2, x minus 1 squared, x minus 5. Okay, so the first thing you want to do are get the zeros of the function. Now, when you have it in factored form like this, it's pretty easy to just read off the zeros. In other words, what makes this whole expression 0? You don't have to look at the 5. I mean, 5 cannot be 0. Okay, now ask yourself, x plus 2. What number, if I were to plug in right here, would give me a 0? Negative 2. What number would I plug in here to get a 0? 1. What number would I plug in here to get a 0? 5. So the zeros of the function are negative 2, 1, and 5. Okay. Right here, the language we would say is x equals 1 has a multiplicity of 2 because it's there twice. I mean, if I were to write this all out, it'd be x plus 2, x minus 1, x minus 1, x minus 5, right? After all, this does mean x minus 1, x minus 1. So we would say later on, x equals 1 is a 0 of multiplicity 2. Okay. Let's say over here there was an exponent of 7. Then I would say x equals 5 is a 0 of multiplicity 7. Okay. So that's basically the idea of multiplicity. All right, so how do I graph this thing? Okay, so right now I have these 3 zeros, right? I put negative 2, 1, and 5. Right? So you know when I plug in negative 2, I get 0. There it is. You know when you plug in 1 here, here, and here, you get a 0. And you know when you plug in 5, you get 0. Because if you put 5 here, and here, and here, well, 5 minus 5 is 0. That wipes the rest of it out, and you get 0. Okay? So right now, all you have are these 3 dots. And then I just ask myself, okay, between the dots, does it go up or does it go down? So we played that game before. Just pick something over here, and something over here, and something over here, and something over here, and you can tell what the sign is, S-I-G-N, and that'll tell you whether it goes up or down. Okay. So I have right here negative 2. All right, so I could pick -3, something in between, like -1, or sorry, 0. 0 is even better, or 2, or 6. Now, the last time I taught the class, I actually put 6 first for some reason, but since I got it, I might as well just keep it. Why don't I just use the 6? Okay, so I picked something over here, 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 and here. It's almost like the region breakdown that we did before. Okay, so something bigger than 5, something between 1 and 5, something between -2 and 1, and something less than -2. Okay? And if I get a positive, I'll just graph it above, and if I get a negative, I'll graph it below. Okay, 6 is easy because what happens when you plug in 6? Everything is positive, right? Positive, positive, positive. They're all positive. So 4 positives makes a positive. So I just go like that. It shoots off to infinity, essentially. Okay, and something else I want you to notice here, I put a little 5 here. 5 is always positive, obviously. So that 5, that's all of these pluses, plus, 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 plus. Okay, so even before you start the rest of the chart, these are all pluses because of 5. And you notice right here, they're also all pluses. Why are these also pluses? That's the third thing here. Take a look at this. What do you know about x minus 1 squared? As long as I don't plug in 1, it's always positive. And I'm not plugging in 1 now. I already did, and I got a 0. Okay, so plus, 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 plus. So the only ones I have to check the signs for are the second one and the fourth one. 5 is always positive, plus, 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 plus. X minus 1 squared is always positive, plus, 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 plus. Okay, so this column here, the second one, must be for x plus 2, and this last one must be for x minus 5. Okay, so we're done with 6. Okay, -3. -3 plus 2, negative. -3 minus 5, negative. So the grand total is I have 2 positives and 2 negatives. That makes the whole thing positive. Okay, so that means -3 is over here. It shoots up to infinity. So it goes that way. All right, then something between -2 and 1 is like 0. So I plug in 0. See, right now, the graph, I have this. I go from here to here. So what does it do? What does it do in between? Well, it's either going to go up or it's going to go down. Right? There's nothing else you can do. It's not allowed to go straight across because we already found all the zeros of the function. So does it go up or down? Pick a number in between, like 0. 0 plus 2, positive. 0 minus 5 is negative. So if you multiply 3 positives and a negative, you're left with a negative. So that means it goes down. So just have it curl down and up. Notice I don't put down how far down does it go. Notice I didn't even put any y coordinates here. Okay. How far down does it go? It might be 1 unit, it might be -2, it might be -80. We don't know. All we know is it just goes down and comes back up. Okay, then I do the same thing with 2. So plug in 2. Here, 2 plus 2, positive. 2 minus 5 is negative. So once again, I have 3 positives and a negative, giving me a negative. So negative means between 1 and 5, I go down. So there's my entire graph. Okay. Down, up, and there we go. Okay, and for these polynomials, yes, once you get past the last 0 and before the first 0, it's either going to go to infinity or negative infinity. It would either shoot up or shoot down. Same thing on this side. That's the way polynomials always work. So they always go to infinity otherwise. Okay. All right, so we'll do more of these, but now I'll get ready to start some of the homework problems. Let's see, page 143, number 9. And yeah, let me go ahead and do this for those of you that aren't going to get the book and never want to get it. So homework problems, page 142. Okay, so here's that part, a little bit more. Then on page 143, that's up to about 16 or 17, so a little bit more. Yeah, there's the rest. And see. Next page. Not sure we have to do any of these. All right, there it is. Up to about 38. Here's 39. And that's the rest of it. Okay, so you have all the problems now. 3.2. All right, page 143, number 9. Sketch the graph of the function by transforming the graph of a function of the form g of x equals x to the n. X to the n. Okay, so we have some problems like this. Let me show you number 9. X minus 2 to the 4th power plus 1. Okay, so you should be somewhat familiar with x to the 4th. Okay, it looks sort of like that. Okay, it's not quite a parabola like x squared, but it still has the same general shape. It's sharper, so it goes like so. Okay, you should know x squared, x to the 4th, x to the 6th, 8, 10. They all look something generally like that. Okay, they go through the origin. Vertex is the origin, 0, 0. Right? Well, you can tell that if you plug in 0, you get 0. Okay, and do you recall what happens here? This is a translation. If you change x to x minus 2, that moves the graph 2 units to the right. Plus 1 means 1 unit up. And of course, you're welcome to put that in your next cheat sheet as you want. Okay, so I just shove it all over here. So the vertex, which used to be 0, 0, is now 2, 1. So I just move over to 2, 1 and just draw the same basic shape myself. Okay. By the way, quick double check. What do you get when you plug in 2, right? 2 minus 2 is 0. 0 to the 4th power is 0. Plus 1 gives you 1. So you do get indeed 2, 1. Next one. Negative a half x minus 3 cubed minus 3. So you should know what the basic cubic function looks like, right? Cubic function. Okay, so here's the progression. Okay, it might be kind of hard to see. Ignore the red temporarily. Look only at the blue. If I can show you that. I'm trying to cover up the red. Okay, x cubed looks like this. This is x cubed. Right over here. So it passes in the first and third quadrant. It is an odd function, you might recall. Okay. So all the odd exponents look like that. X to the 1, by the way, what is x to the 1? That's just x. That's a straight line, right? Even a straight line passes through quadrants 1 and 3. But x cubed, x to the 5th, 7th, 9th, 11th, they all have that same basic curve shape like that. Okay, now I'm multiplying x cubed by negative a half. So the negative is going to reflect across the x-axis, and the 1/2 means it's not going to be as steep. It's going to be spread out more. Okay, so I've got it kind of curved like so. Okay, so negative a half x cubed goes something like so. Positive a half x cubed would kind of go like that. That's what I'm trying to indicate with this red thing here. And then the reflection across the x-axis would be this, negative 1/2 x cubed. Okay, so the red is negative 1/2 x cubed. And now what's the effect of this? So I take this red graph, move it 3 to the right, and then 3 down. All right, 3 to the right, 3 down, which means the easiest way to do that is just take the origin. So where does the origin move to? If I go 3 right and 3 down, it's 3, negative 3. Okay, so coming back up here, this is my final answer. I just essentially took this graph, moved 0, 0 to 3, negative 3, and just drew the same general shape. So there we go. Okay. All right, so that's a couple of those problems. Now we're going back to graphing stuff like this. So use the zeros and end behavior of the polynomial to sketch an approximation to the graph of the function. Okay. Now you should show me this analysis on the homework. and quizzes and exams. Okay, you know and I know there are graphing calculators that you can just push some of the right buttons and it shows it to you. You're not supposed to use that primarily as your only source. Now I don't mind you use that as your double check, but you should show me as much work as I'm showing right now. Put it that way. Okay, and then if you just want to punch stuff in a calculator, well, anybody can do that without even knowing what's going on. But I want you to show me the same kind of analysis as I'm doing now. Okay, so I'll show you how to do some of these. The way to do these is somewhat similar to what I showed you over here. Okay, so end behavior. What is end behavior? End behavior is past the last zero and before the first zero. It means going way out as x goes toward infinity, as we say, and x goes toward negative infinity. So end behavior for this example that I give you here would be past 5 and before negative 2. Okay, so again, it's after the last zero and before the first zero. Okay, it's always going to go either to infinity or negative infinity. Same thing here. Excuse me. Okay, so it's going to go either to infinity or negative infinity. Here are symbols. You get used to this symbolism quite a bit when you get to calculus. When you get to calculus, they'll use this all the time, so we're getting you set up for that. When you draw x, arrow, infinity, we say x approaches infinity. That means you're plugging in bigger and bigger and bigger numbers, 100, 1,000, a million, a billion, a trillion. When you put x, arrow, negative infinity, we say x approaches negative infinity. So you're plugging bigger and bigger negative numbers, negative 100, negative 1,000, negative a million, negative a billion, negative a trillion, and so on. Okay, so when you go all the way out, either to the left or to the right, you're either going to shoot way up or way down. Okay, so you're either going to go like that, or maybe like that. Okay, you'd always go to infinity or negative infinity. Okay, so here's problem 13. And again, the graph is already there, unfortunately, but let's pretend you don't know that. Okay, f of x equals x minus 2, x plus 2, x minus 3. Quick sketch. All right, so first you lay down the zeros of the function. Okay, what number makes this 0? What number makes this 0? What number makes this 0? So it looks like there's going to be 3 zeros. Okay, so what number makes this 0? 2. What number makes x plus 2 0? Negative 2. What number makes x minus 3 0? Positive 3. So these are my 3 zeros, as we say. Okay. So in other words, if I plug in 2 here, here, and here, you get 0, right? Because if you plug in 2 minus 2, it's 0. Since 0 times anything is 0, so the whole thing is going to be 0. And let's say if I plug in negative 2, plug in negative 2 here, and here, and here. Well, if you plug in negative 2 here, negative 2 plus 2 is 0. So 0 times that and times that is still going to be 0. And likewise, 3 over here. Okay, so at the start, your graph, again, looks sort of like this. I only have the 3 red dots. So I picked something over here, something in the middle here, this tiny little middle piece here, and something over here. Okay, so over here and here, to the left of negative 2 and to the right of positive 3, that's considered end behavior. It's either going to go to infinity or negative infinity. You just need to determine the sign. Okay. So what I did over here was I decided to plug in 1,000 and negative 1,000. Okay. You don't have to, but that kind of clinches that something is very big. Okay. See, if I plug in 1,000 here and 1,000 here and 1,000 here, it's clearly positive, right? 1,000 minus 2 is positive. 1,000 plus 2 is positive. 1,000 minus 3 is positive. So positive times a positive times a positive, positive. So that means I know right over here it goes to infinity. Okay, negative 1,000, a super big negative number. You can tell right away that these are all going to be negative, right? Negative 1,000 minus 2, negative. Negative 1,000 plus 2, negative. Negative 1,000 minus 3, negative. What is the exact value? I don't know. I don't care. I'll just know that it's all going to be negative. So 3 negatives make a negative, so it shoots down like so. And there we go. Now, what about these 2 regions? Okay, I didn't do it, but you would have to do it. Just plug in a number. So what's a nice number in the middle? Right there. 0. Looks like it's going to be positive. So if you plug in 0 here, and 0 here, and 0 here, that shows it to you. Okay, I didn't put it here, so this was like my etc., but you can kind of tell. 0 minus 2 is negative. 0 plus 2 is positive. 0 minus 3 is negative. So we have two negatives, right? So two negatives makes it a positive. So I just have it go up. Now, notice I didn't put how far up. You can tell by plugging it in. If you plug it in, I think it's 12, but you don't really care. It just goes up somewhere and comes down. And by the way I drew it, it looks like 12 is a maximum point here. I don't really know that. It may or may not be the highest point. Maybe it goes up like that and shoots down here. Or maybe it goes like that and it comes down. You'll learn those techniques when you get to calculus. Calculus, you'll learn that. Okay, then do the same thing with what? What numbers between 2 and 3? Well, 2.5. So 2.5 minus 2, positive. 2.5 plus 2, positive. 2.5 minus 3 is negative. So there's one negative. That makes the whole thing negative. Okay, so I have it going down and up. So there's a quick and dirty sketch of the whole thing. Okay. All right. 17. F of x equals negative x cubed times x minus 1. Okay, so just get the zeros. What number makes this 0? 0. What number makes this 0? 1. So my zeros are 0 and 1. And by the way, here we would say 0 is a 0. Now that sounds redundant. But the number 0 is a 0 of multiplicity 3. Right? If you wrote it all out, it'd be negative x times x times x. So there's really 3 x's. Okay, so we say the 0 of multiplicity 3 is 0. And x equals 1 is multiplicity 1. Okay, so I have that and that. What about the rest of the graph? What happens when x goes to infinity? Okay, so that's to the right of 1. I put 2. I could put in a million. That works. Let's just plug in 2. Put a 2 here. Negative 2 cubed, that's negative. 2 minus 1, positive. Negative times a positive is negative, so that means it shoots down. Okay, so it's end behavior. As x gets bigger and bigger and bigger, super and super and super big numbers, then y drops to infinity, negative infinity. Y drops down. And likewise, x approaches negative infinity. I plug in negative 1, but you can plug in negative 80 or negative a million. Let's plug in negative 1. Okay, if you put negative 1 here, you've got to be a little careful. Ignore the minus sign in front now. What is negative 1 cubed? Negative 1 cubed is negative 1. But the negative in front of that whole thing makes it positive. Okay? So that's going to be positive. And then negative 1 minus 1, negative 2, negative. So positive times a negative, which is negative. So that means end behavior on this side also goes to negative infinity. So when x goes way out to the left, okay, x goes way out that way, y drops to negative infinity. Okay, then all I have is what happens between 0 and 1. It either goes up or it goes down. So how do you know? Plug in a number between 0 and 1, like a half. So I plug in 1/2. 1/2 cubed is positive, but a negative in front of the whole thing makes it negative. And then 1/2 minus 1 is negative. So negative times a negative is positive. So it looks something like that. Okay. Get that yellow out of there. Okay. I wanted to show you 18. Yes, I know it's an even problem, but it illustrates something here. Okay, so there's 18. I want to show you the multiplicity aspect again. So f of x equals x squared times x plus 1 times x minus 2. So what are the zeros of this function? 0, negative 1, 2. Okay, so the zeros are 0, which we would say is multiplicity 2, because there's an exponent, and negative 1 and positive 2. Okay, so 0, negative 1, and positive 2. And notice what I did here for n behavior. X approaches infinity, I plugged in 100. X approaches negative infinity, I plugged in negative 100. Okay, so I put 100 here, here, and here. It's so big, the +1 or the -2 don't change it very much. They're all positive. So what's a positive times a positive times a positive? Positive shoots up toward infinity. Plug in negative 100. Negative 100 squared is positive. In fact, this thing's always going to be positive. Let's see, negative 100 plus 1 is negative. Negative 100 minus 2 is negative. So a positive times a negative is positive. So on this side, it shoots up to infinity. Okay. And then the other thing I wanted to emphasize was I didn't show you these, but evidently these are going to be negative. Okay, but maybe I can do it now. Okay, so I didn't write it before. Let's plug in. So right now, this is all the graph that we have. Okay. If I plug in 100, I'm looking at n behavior, right? So 100 shoots up like that. Negative 100 shoots up like that. Okay. Now, in the graph, I have it going down. Well, how do I know it doesn't go up? So pick something here and here. Okay. Yeah, why don't I just do that right now? So what's a number in here? How about negative 1/2? And what's a nice number in here? How about 1? Okay. So right now I have this, but I need to know between these two zeros, does the graph go up or does it go down? And between these two zeros, does the graph go up or does it go down? Okay, so why don't I go ahead and do this sign chart for you? Okay. And I might as well just do this automatically, right? I know these are plus because it's x squared. So I have it for x squared, these are automatically plus. Okay, negative 1/2 plus 1. Negative 1/2 plus 1, positive. Negative 1/2 minus 2, negative. So I'm going to have a positive times a negative, negative. It goes down. Okay. Mind you, I don't really know how far down it goes. And the way I drew it, negative 1/2 is the minimum value. But I don't know the negative 1/2 is the minimum value. The minimum value might be maybe over here or maybe over here. I'm just doing this out of convenience. When you get to calculus, you'll learn techniques to finding out these minimum points. And likewise, evidently 1 makes it go down. Let's see why. Okay, so we already know this is positive. 1 plus 1, positive. 1 minus 2, negative. So positive times a negative, negative. So there it is, it goes down. So that's what we have for that one. All right, so I think I'll show you 19, and maybe that's about it for today. What time is it? 9 more minutes or so, we'll see. Negative x squared, parentheses x plus 1 squared. Okay. This one's a little bit different. I drew the graph fairly quickly here. So how can I do that? All right, so what are the zeros of the function? 0. Multiplicity 2, we would say. So multiplicity, multiplicity, it's in the book. And negative 1, multiplicity 2. Okay, so there's that, and there's that. Negative 1, negative 0. Okay. So now what happens the rest of the time? Okay. Now, how did I come up with that graph fairly quickly? Okay. Here's how. Ignore the negative sign just for a moment. Tell me something about x squared if I plug in any number besides 0. Positive. Tell me something about x plus 1 squared for any number besides negative 1. Positive. Okay. So we already have the zeros, negative 1 and 0. If I plug in any other number at all, ignore the minus sign, remember. this expression right here, x squared times x plus 1 squared, is going to be positive, right? You get 0 if you plug in 0. There it is. You get 0 by plugging -1. There it is. But if I plug in any other number, because this is squared and this is squared, right now this expression is positive. Agree? Okay, so that's positive. Now there's a minus in front of the whole thing. What does that mean? Now the whole thing's going to be negative no matter what. So down here, down here, down here. That's how fast that one was. Okay, now you're not always going to have it that easy, but that's something hopefully you would realize that, oh, this expression is always negative. Okay, so make it go down here, make it go down here, make it go down here. Done. So again, so-called end behavior. End behavior means I go to the right of the last 0 and to the left of the first 0. Okay, so end behavior, past the last 0 before the first 0. So what happens to the right of 0 shoots down to -infinity. What happens to the left of -1 shoots down to -infinity. Okay. What clinches is if you plug in a super big number. Plug in 1,000,000, right? If I plug in 1,000,000, 1,000,000 squared, 1,000,001 squared, it's clearly positive. And now the negative means it's negative. And likewise, if I plug in -1,000,000, right? -1,000,000 squared is positive. -1,000,000 plus 1 would be what? -9999999 squared. That's positive. So this is a super big positive. And now the negative makes it a super big negative. There it is. And so what about plugging something in between 0 and -1? You could, but you don't have to. Whatever it is, I know this is positive. This right here is positive, so that minus sign makes it negative. So there it is. It has to go down. Okay. So there we go. All right, folks, that'll do it for today. So I'm going to stop the share and see if there's anything in the chat. And there's nothing in the chat, so I think we're good. All right, so in the last few minutes, if anybody has a question, I'll take it. But if not, we're done for the day. You should have gotten your test scores. I sent a video for the exam answers, right? So if you wanted to check the correct answers with your test you made, most of you did pretty well on the test, so no worries about that. So if you didn't get the video with the exam answers, or you didn't get your actual test score back, then please let me know. But I think I got through everything. You know, everything's crazy. It's very easy for me to forget an email, or I mean, I get hundreds of tests and homework, so it's easy for me to forget. And I always give you the benefit of the doubt. Okay, so I will make the assumption that I messed up. So let's say I didn't get your homework for some reason, I will assume that I messed up, and I'll ask you, did you send it? And likewise for the test and so forth. Okay, so we have it weird, so it's very, very easy for me to mess up too. All right, so any other questions, folks? Otherwise, that's about it. We good? And nothing in the chat? Okay, that's it, folks. So have a good day, and we'll see you all tomorrow. Okay, bye. Bye, everyone. Thank you.